Alright, Math 1, we're going to take a look at some functions evaluations, and we're going to do it in graphs, tables, and equations. The thing to remember is that when we talk about functions, the letter out front, in this case R or G or F, is the name, right? And together, the f of x, or g of x, or r of x, or whatever the variable is in the inside, represents the output. And the x represents the input. Okay? Which that's what we're going to be doing on all three of these versions, is we're going to take a look at, given an input, can we find the output? Given a graph, given a table, given an equation. Then also, given the output, can we go back and find the input in each one of those? Okay, so let's take a look and see how it goes. So g of 2, so remember, on a graph, the input is the x value, the output is the y value. Okay, so g of 2 means I go to this x value of 2, and then I go up on my graph until I find that y value, so the point would be right there. I have an x value of 2, y value of 9, right? So that would be equal to 9. For C, g of 0, x value of 0, go up, hit my point, y value of 1, so g of 0 equals 1. And then B, g of x equals 3, so on the y now I go up to 3, jump over, find my point, go down, x equals 1. And that's all there is to it on these. Okay, so number 2, r of negative 1. Negative 1 right there. Go up, looks like it's at 10. Then r of 2, go up, it's going to equal 1 for the y value. R of x equals 4, y value 4, jump over, down, my x value is 1. Okay. 3, f of x. So f of 4, go to 4 on x, hit my y value of 1. F of negative 4. Well, at negative 4, I'd have to go off the page, wouldn't I? So let's keep going. F of x equals 4. Y value 4, it's my y-intercept, so x equals 0. Okay, so notice I've got those 2 points. So to find b, my slope, I'm going down 3 to the right 4. So going backwards, I go to the left 4 and up 3, which would take me to 7. So f of negative 4 would take me up to positive 7, so f of x equals 7 would take me back to negative 4. Okay, number 4, g of x, so g of negative 1, down, that's going to be negative 2, g of negative 3, down, that's going to be negative 3 as well. G of x equals negative 4. Actually, whoa, negative 4, wouldn't it? What was I thinking? So, I already see that those are connected, so if this is negative 4, this has to be negative 3. So it has to work backwards too. Then g of x equals negative 1. That's my y-intercept, so x would equal 0. Okay, number 5, h of x. H of 0, it's my y-intercept, it crosses at negative 5. H of 3, looks like it goes down, I would guesstimate that's at about a half. H of x equals 1, so my 1, positive 1, not negative 1, 1 hits right there, x equals 4, and then negative 2 hits at positive 2. And finally, d of x, d of negative 5, hits at the y value of 1, d of 4 hits the y value of 2, d of x equals 4, y value of 4 hits at x value of 3, and 0 hits at 0, so x equals 0. So, when we're graphing, that's all we got to deal with the graph. Okay, now let's take a look at tables. So with tables, again, our input and our output. Inside is input, so f of negative 1, okay, would say my output is 1. F of 2, my output would be 4. Now going backwards, what if my output's 4? Well, that takes me back to 2 for x. My output is 1, that takes me back to negative 1 for x. And that's all we're doing on these ones. Okay? So for number 2, g of 0 equals 1. G of 3 equals 8. If g of x equals 8, it's back to 3, right? And if g of x equals 2, it's back to x equals 1. So f of negative 1 would take us to 5. F of 0 would take us to 6. F of x equals 5 takes us back to x equals negative 1. F of x of 6 takes us back to x equals 0. Okay, g of 0 would be 2. G of 1, 14. G of x equals 2. X equals 0. G of x of 6, 86 would take us to an input of 3. Okay, number 5, f of negative 1 gets us to 10. F of 1 to negative 130. F of x equals 10, back to negative 1. F of x equals negative 60, an input of 0. G of 0 equals 6. G of 2, 24. F of x, or g of x, 12, takes us to x equals 1, to 24, x equals 2. Okay, negative 1 to negative 10. F of x equals negative 10, so that x would be negative 1. 0 and 10 are connected, so f of 0 would be 10. Negative 20 and 1 are connected, so positive 1 for x. And 2 and 20, so 20. Okay, just those points again. So g of 1 is 100, g of 3 is 4, g of x equals 4 goes back to x equals 3, and for 100 back to x equals 1. Okay, f of 0 would be 150, f of 1 would be 160, 150 as an output would take us to an input of 0, 170 output, input of 2. Okay, number 10, g of 1 is 16, g of 2 is 4, g of x equals 1, x equals 3, and 4 matches with 2. F of 1 is 1, f of 2 is 2, f of x equals negative 1 is x equals negative 1, and f of x equals 2 is x equals 2. 12, g of 2 equals 20, g of 3 equals 40, g of x of 5, x equals 0, g of x of 10, x equals 1. 13, f of negative 1 is 1, f of 2 is 16, f of x of 9 takes us back to 1, and of 16 back to 2. G of 0 is 7, g of 3 is 56, 56 goes back to 3, and 14 goes back to 1. F of negative 1 is negative 9, f of 0 is negative 8, f of x equals negative 8, takes us to 0, and of negative 7 back to 1. And the last table, g of 0 equals 1, g of 1 equals 5, g of x equals 25, back to 2, and of 5 back to 1. That's all we got to do when we're dealing with the tables. Okay. The final thing is dealing with the equations. So with the equations, what we do is we take the number, the input it wants us to find. So it says find f of negative 9. So I'd go f of negative 9. And anywhere there's a t, I'm going to replace it with negative 9. So f of negative 9 equals negative 9 plus 3. Then I'm not going to touch that left side. Okay, that f of negative 9, remember, represents the output. Okay, I'm not trying to separate the 9 from the f. The f's just the name, the 9 is the input. All I do is evaluate the other side. So negative 9 plus 3, negative 6. And there's my answer. Just like these, set up the answers just like these. Okay. So for 2, we've got f of negative 6 equals 2 times negative 6 minus 2. 2 times negative 6 is negative 12 minus 2 is negative 14. So f of negative 6 equals 14. For 3, f of 10 equals 4 times 10 minus 3. 4 times 10 is 40, minus 3 is 37. F of 10 equals 37. F of n equals 3n minus 4. We want to find f of negative 4. So we go 3 times negative 4 minus 4. Be negative 12 minus 4 is negative 16. F of negative 4 equals negative 16. Okay, number 5, g of 2 would equal 3 times 2 minus 3. 3 times 2 is 6 minus 3 is 3. So g of 2 equals 3. Number 6, w of 0 would equal 4 times 0 plus 3. So w of 0, 4 times 0 is 0, 0 plus 3 would just leave us with 3. So h of 10 would equal 2 times 10 plus 4. 2 times 10 is 20. 20 plus 4 is 24. H of 10 equals 24. So pretty simple and easy to see what's happening here, right? P of 8 would equal negative 4 times 8 plus 3. Negative 4 times 8 is negative 32 plus 3 is negative 29. So P of 8 equals negative 29. Okay, H of negative 2 would equal 2 times negative 2 minus 2. So negative 4 minus 2, negative 6. H of negative 2 equals negative 6. Okay, number 10, g of 9 equals 2 times 9 plus 5. 2 times 9 is 18, plus 5 is 23. G of 9 equals 23. Okay, so for all these linear ones, pretty easy to see. You just plug the number in and solve. Okay, so g of 10, negative 10 equals negative 30. Now, those have all been linear, pretty simple, right? Now, what about if we have an exponential? Now, this one looks a little more complex, but we treat it the same. We replace the variable with the input, and then using order of operations, we solve. So we deal with this exponent first. 2 minus 1 is 1. Okay, 5 to the first is just 5. 3 times 5 is 15. 15 plus 2 is 17. And following the order of operations, we have h of 2 equals 17. So it doesn't matter how complex it gets. Okay, we still treat it the exact same way. So w of 0 equals negative 2 to the 0 plus 1 power minus 2. Negative 2 to the 0 plus 1 is 1, minus 2. Negative 2 to the first is negative 2, minus 2. Gets us w of 0 equaling negative 4. Okay, 14, w of x equals 3 to the 0. Okay, and then hopefully you know that anything to the 0 power equals 1, so w of 0 equals 1, and I should change that to 0. 15, h of 1 equals 5 to the 1 minus 2. 5 to the 1 is 5. Minus 2 gives us not 7, 3. So h to the 1 equals 3. Okay, number 16, g to the 0, and these are all exponential, aren't they? 3 to the 0 plus 2 be 3 squared. 3 squared is 9, so g of 0 equals 9. So again, input of 0 gives me an output of 9. 17, f of 1 equals 2 to the 3 times 1 minus 1. So 2 to the 3 minus 1, 2 squared, which is 4. So f of 1 equals 4. For 18, f of negative 2 equals negative 4 to the negative 2. Now, if you didn't know the rule about negative exponents, those actually become fractions, so it would be 1 over negative 4 squared, which negative 4 squared would be a positive 16, so we'd get f of negative 2 equals 1 over 16. Kind of an ugly one, but we still deal with it. Number 19, w to the 0 equals 4 to the negative 0 minus 2. Negative 0 is just 0. So 1 minus 2 would be negative 1. W to the 0 equals negative 1. Now these last three, notice we've got multiple variables, different powers, but it doesn't matter. We treat it the same. H to the negative 7 equals negative 7 squared plus negative 7. Negative 7 squared is positive 49, plus negative 7 is subtracting by 7, so h of negative 7 equals 35. And 21, f of negative 8 equals negative 3 times negative 8 squared minus 2 times negative 8. So, negative 2 and negative 8, positive 16, negative 8 squared, positive 64, times by negative 3 is negative 192 plus 16, and that ends up being negative 178. So f of negative 8 equals negative 178. So hopefully you noticed that I never messed with this side. Okay, I see that a lot where people try to divide by negative 8 or divide by f. You don't do that. Okay, last one, p of negative 9 equals negative 9 squared. So that first negative is outside the square. So negative 9 squared is 81, but this negative still sticks with it, and we get negative 83. So p of negative 9 equals negative 83. Alright guys, there we have it. There we go.